Assalamu alaikum. Hello everyone. My name is Muhammad Tabi. Today my colleague and I are going to present you our topic, which goes by the title Aqua-Fi Underwater Communication. Our outline goes like this. First, what is Aqua-Fi? Second, ways of transmission. And lastly, we are going to finish with the future of Aqua-Fi. What is Aqua-Fi? Simply, it is a way to communicate under the water, but wirelessly. So we can describe it as Wi-Fi, but water instead of air or free space. Why do we need Aqua-Fi? First, to reduce the need of the wire, as they cost a lot of money. Second, it can be installed for temporary usage. So instead of installing and removing mountains of wires, we can use Aqua-Fi instead. Third, it can be used for military applications to send and receive signals from submarine, as an example. Ways of transmission. There are several ways to transmit signals under the water. The first one, by using mechanical waves. The mechanical waves need a medium to travel, which is applicable to our case, where we have a water as the medium. And they are shown to travel under the water effectively, but unfortunately, they travel with the speed of the sound, which is relatively slow, which will result on a low data rate. The second way, by using an optical waves. Optical waves is an EM waves that uses a wavelength of 100 nanometer to 1 millimeter. From the spectrum here, we can see it ranges from UV to IR. This is considered as a better option, as EM wave will travel at a speed close to the speed of the light, which will guarantee a very high data rate. But unfortunately, seawater is an impure medium. Therefore, scattering and refractions become an issue. Optical waves can be transmitted either by using LED or laser. Why don't we use radio frequency waves to transmit the signal? As we know, radio frequency waves also considered as an EM wave, but with a higher wavelength. Unfortunately, they are not practical for a high distance application like it is needed here. But it can be used for a short distance application, as can we see in the left figure here. That was my part. Now I will leave you with my colleague Omar. Thank you.
Assalamu alaikum warahmatullahi wabarakatuh. Now we want to talk about LEDs versus lasers. When we talk about optical transmissions, these are the two main ways, and LEDs are more cost effective and have a smaller footprint as they are smaller in size and use less power. Laser, however, is more effective in transmitting high data rates over longer distances than the LED counterpart. As we can see here, LEDs, when going at high distance, we must sacrifice a lot of the data rate and put a lot more power into the transmission. Lasers, however, can offer up gigabit data rates over relatively high distances as compared to their LEDs counterparts. Of course, we don't want to transmit over long distances like 10 kilometers or 20 kilometers. We must use acoustic waves. Although acoustic waves also suffer from some disadvantages like multipath, which cause a lot of ISI, sorry, and the Doppler spread is also very noticeable. Next, we want to talk about the future of Aqua-Fi. The future of Aqua-Fi is very bright. We have many new techniques developing in underwater communication. For example, energy harvesting, which is a way to take the excess power from the transmission and turn it into energy to charge batteries and so on. Of course, energy harvesting is right now popular everywhere, but it's being adapted in underwater communications as well. Second, we have massive adaptive MIMO. MIMO is, of course, multi-input, multi-output, and it's very good in supporting large array of hydrophones for underwater communications and many underwater sensors for to communicate with each other with single hub. It can allow for various types of communications like videos and audio conferencing underwater, which is very good for this type of application. Next is millimeter waves. Millimeter waves are also very important for underwater communications. Underwater communications could use millimeter waves underwater as the high frequencies allow them to uh, travel underwater. Next is the non-orthogonal multi-axis. Is also an emerging underwater carrier or carrier for underwater communications. Non-orthogonal multiple access is offers desirable communication benefits and promising multiple access techniques. It allows to connect multiple users simultaneously and minimizes the delay. Lastly, we want to talk about the Internet of Underwater Things. Internet of Things is, of course, popular everywhere right now, but it could also be integrated for underwater communications, as many underwater sensors can communicate with each other to provide a better result. That was it for our presentation. Thank you for listening, and goodbye.